One of the things that we didn't get to during our Saturday review was use of the z-table. We used the empirical formula to interpret the distribution of population or probabilities in a normal distribution. But we can get around to reviewing once again for one last time before the exam the use of the z-table to figure out the exact areas of the curve that we need. Okay, for instance, here's a picture of the distribution that's shown with our empirical formula. 68% of the population, or 68% chance of picking an individual that falls within that range, is between one standard deviation below the mean and one standard deviation above. 95% is between two standard deviations below and two standard deviations above the mean, and 99.7% is within three standard deviations on either side of the mean. Okay, in a perfect normal distribution. Well, we're going to go ahead and apply that. Okay, and here's for instance, a question on one of the, from assignment 2. Research examined in Haynes survey to estimate dietary intake of certain ingredients by the participants of the study. One of those nutrients was calcium. The intake was measured in milligrams for adults 60 years and older. They found a mean of 721 milligrams with a standard deviation of 254. So let me just go ahead and put that down here. We had a mean of 721, so our mean will be mu. Oops, make sure that this is working. A little bit of a problem here. Mu equals 721, and our standard deviation was equal to 254. Sigma equals 254. Just as a review again, you guys that were tuned in this morning heard this already, but for those of you guys that missed it, I didn't want you to not have this when you looked at the video that was online. We missed this part because it was a little technical problem. The rest of it is recorded though. So when we use Greek letters, we're referring to parameters. We're referring to values for the population. This represents the population. When we're using letters like X bar, right, or S for standard deviation, those are intended to describe the sample, statistics. Those are statistics, and they describe the sample. Okay, so if you see me say mu and sigma, I'm referring to the population. If you see me saying X bar and S, I'm referring to a sample from that population. These are parameters, these are statistics. Okay, so at any rate, let's take a look at this information. So the mean is 721. Oops, 721. And standard deviation is 254. That's pretty wide. So I know, let's see, 721 minus 254. I can barely read that. Okay, that's 111. That would be 7, 6, my goodness, 6, 467. So 467 would be one standard deviation below the mean. I know between 721 and 467 that I would have about 34% of the population would fall within that range. Okay, and how do I know that? Well, the empirical formula. Empirical means that it's not based on exact numbers, that it's based or calculations. It's based on either general knowledge or experimentation and so on and so forth. When we get around to it, we'll get the exact numbers from our tables and so on and so forth. So this is an empirical method, an estimate. So 68% is between one standard deviation below and one standard deviation above. That would be 68%. We know there would be half of that, since this is symmetrical, that would be one standard deviation below, or between 721 and 467. Well, in this case, this problem is asking us, using these values, well, let's see, move up and see what it's going to ask us. Compare the probability that a single randomly chosen adult over 60 years old will have a daily calcium intake of over 900 milligrams. Okay, well, you know, let's see, 900. Let's see where one standard deviation above would be. So if I added those two together instead, it would be 5, so 7, it'd be 975. Yeah, one standard deviation above is going to be all the way up at 975. It'd be too far up for us. So it isn't going to be easy to use this empirical formula to really calculate this very accurately, because I really am kind of constrained to an estimate that involves an exact number of standard deviations above and below. So let's do this on a chart of our own making. Okay, again, the mean is 721. The standard deviation, if I'm correct, is 254. 254, and I'm looking for the percentage of adults that might be over 900. Okay, so here would be 721. Let's see, I think 900 is probably going to be around here, since it looked like it was a bit less than one standard deviation. It's going to be around here, 900. Okay, and I want to know what percentage of adults, percentage of this population, that's above a calcium intake of 900. Okay, so now you could interpret this a lot of ways. You could interpret it as being an area that represents the percentage of the population. You could also interpret it as the probability that if I picked a random individual from this population, that's the probability that I would pick someone from this area, since that represents how much of the population is represented. So in other words, if this was 30% of the population, probably I'd pick somebody from there would be 0.3. Okay, so we're going to find out exactly what it is. In order to figure out exactly what it is, I have to interpret what this area is. It wasn't easy for me to use the empirical formula, because the number of standard deviations above the mean is not a whole number in this case. How do I figure out how many standard deviation above the mean this is? I calculate the z-score. And the z-score is really the number of standard deviations above the mean, and it can have a fractional value in our case now. So a formula I could use if I wanted to. I could calculate it in my head pretty easily, but a formula I would use would be something like x minus mu, in other words, the value I'm interested in minus the mean, over the standard deviation. Okay, so what is that? That's 900 minus minus the mean 721 over 254. Okay, it's just if this were 250, the difference with 254, this would just come out to a z-score of 1, which is exactly what we would expect. So let's figure out what this is. 900 minus 721. Let's get a calculator. 900 minus 721 divided by 254 is a z-score of 0.7. I'm going to leave it rounded off to 0.70. Equals 0.70. Well, what percentage of the area is in this upper part of the curve? Well, we have tables. This is the table, z-table, representing the areas for all of these different z values. In fact, if we look over here, we know that one standard deviation above here would have represented 16%, and that would leave 86% to be to the left of this. We know that from the empirical formula, because the area between the mean and here and one standard deviation above is 34%, half of the 68% between -1 and +1 standard deviation. Okay, if I look over here to a z-score of 1.0, indeed it is 84% the area to the left of this. Okay, so now let's figure out what the area to the left of 900 is. 900 represents a z-score of 0.7. So a z-score of 0.70 would be 0.7, okay, and it'd be into the 0 column because the next digit is 0. It'd be 75.8%, 0.758. Okay, now keep in mind, this is represented by the area, that z-score is represented in this table, the area is represented in this table as being to the left of the value of that z-score. So it's telling us that this area to the left of the z-score of 0.7, or a value of 900, that area is 0.748. right, or 74.8%. Okay, that leaves this area to be 25.2%, right, or 0.252, because it's got to add up to 100% or a probability of 1. Okay, so that is the area that's left for us there. We had to interpret it because it only gives us the area to the left. Well, now let's see if I asked you, well, let's figure out what percentage of the population has a calcium intake of less than, let's say less than 300. Okay, so 300 is going to be down here somewhere. I don't know exactly where, but this is the percentage of the population that has a calcium intake of less than 300. I could also interpret it as the probability of picking someone at random from this population and finding that they have a calcium intake of less than 300. So now I would calculate my z-score again. So my z-score is going to be equal to, that value 300 minus my mean, which was 721, over my standard deviation, which is 254. Well, z in this case is going to be equal to, let's see, 300 minus 721. 300 minus 721 divided by 254. That's a z-score of minus 1.66. I'm going to round it off for my purposes. I encourage you not to round off until you're done with your calculations if possible. Minus 1.66. Well, why a minus sign? Well, because this number, the x, was smaller than our mean, so when I subtracted our mean, it came into a negative number, but that also means that the value is, as expected, to the left of the mean. Okay, so the z-score is minus 1.66. Well, you have two tables, actually. I kind of held back on that. You actually have two tables. You have this z-table, which is for values, a positive values is z, and in your open source textbook, they also give you a second table for values that are negative values of z, negatives, and so on and so forth. Notice how like the areas for the negative ones are always to the left of the mean. Okay, so in our case, 1.66 would be 1.60123456. It'd be 0.0485. I'm going to call it 0.049. Okay, so that's 0.049. Okay, is an area 4.5%. That z-score represents an area to the left of that value, that z-score value. To the left of that would represent, I'm going to call it 5% for my purposes. Okay, so this area is 4.9, or if you'll allow me, I'll just call it 5% of the population. Okay, we determined those both using the z-table. Okay, so now just a caution, you're going to have to interpret what the questions are asking you for. For instance, it might have asked you, what's the percentage of the population or the probability of picking someone who has a calcium intake above 300. Well, you would have to calculate to the left first, so you'd figure out above 300. Well, 300, for my chart, 5% of the population is below 300, so that means 95% would be above. I might ask you what percentage of the population is above, is below 300 or above 900. Well, then it would be the sum of 5% and 25%, right? The sum of these two areas. Or I might ask you, what's the percentage of the population that has a calcium intake between 300 and 900? In which case, you'd add these two together, 5% and your 25%, 30%, leaving 70% here in the middle for the value, for the percentage of people consume between 300 and 900 milligrams per liter of milligrams of calcium. Okay, so there's a lot of ways they could apply these problems, but the key here is to get used to interpreting the values in your z-table and understanding what these areas represent in terms of your z-table. Just one more thing. one of the things that you might be asked is, for instance, is, well, what would I expect? Uh, 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 what would be the value that would represent um, the number, the calcium intake that would represent a value below which only 10% of the population is consuming? So I'm asking here, I know the area is 10%. What's the value? What's the number of milligrams of calcium that are being consumed that might represent? Well, in this case, I know the area, but I don't know what the value is. Well, the table will help me with that. It won't tell me the value. It'll tell me the z-score. So I want to know what number represents, what z-score represents an area of 10% at the bottom end of this curve. So I'm going to go over here. I'm going to look for what area. Let's say I'm going to use the negative one because I know that one's to the left of the mean, so it's going to represent. So I want to find only 10%. So if I move my way through here, 10.2, 10. What it looks like that is the closest z-score to that is 1.28 is the closest to about a 10% area. The numbers in here all represent areas. The numbers on the columns in this column and at the top of the various columns are part of the z-score. So what did I say it was? I said it was 1.28. Okay, so now I can go back here and say, well, this has a z-score equal to 1.28. So what's the value? Well, I can back calculate. Okay, 1.28 is equal to x minus 721 over 254. And since I know everything except the value itself, I can solve for x and find out what that value is. Easy way to do that usually is to cross multiply